This is Santamaria, Maestro, researcher from the Politécnica University of Madrid, presenting the paper named Advanced Point Cloud Processing Methods for Supporting the Diagnosis of Historical Buildings, a case study of Guimarães Castle Keep Tower in Portugal. This research was made in collaboration with the researcher Pablo Sanzonrado and the professors Serafín López Cuervo and Luis Javier Sánchez Aparicio. As a brief resume, this publication proposes an innovative approach that resorts on the use of several advanced 3D-point cloud processing strategies. Regarding the state-of-the-art of automated classification, several academic papers were assessed in order to determine the current situation and needs of this field, obtaining the following conclusions. There is a lack of an homogeneous multi-level and multi-resolution approach, a predominant use of random forest in machine learning strategies is observed, and finally, there is a need for a reproducible process impervious to the subjective influence of an operator. Talking about automated damage detection, thanks to the systematic review carried out by Sánchez Aparicio in a previous work, it was observed an absence of constructive system segmenting methodologies prior to damage assessment, as well as the need to increase performance validation of algorithms and a trend towards automation in the diagnosis of historical buildings. As it was stated previously, the chosen study case was the Guimarães Castle Keep Tower in Portugal. Being one of Portugal's most significant landmarks, this 10th century fortress and its surroundings have been recognized as a UNESCO World Heritage Site since 2001. Currently, the building shows several damages related with out-of-plane movements along its facade, as well as the deflection of its timber elements, as previous academic works have shown. Taking into consideration the state-of-the-art review carried out, the following methodology is presented. The input for this procedure is the 3D point cloud obtained through a terrestrial laser scanning campaign, which provides a reliable source of information. This process comprises three main stages: pre-processing of the raw data, semi-automatic classification of the 3D point cloud in construct elements, following a machine learning approach, and automated damage detection following the classification system proposed by Sánchez Aparicio via different advanced processing algorithms relying on geometrical features such as ransack, deflection evaluation, and point-to-primitive distances. Diving onto the multi-level, multi-resolution approach, this image shows the three levels proposed, with the different constructive elements, its search radius, and resolution. Heading onto the experimental results, a machine learning was applied following the previously mentioned workflow, allowing for the automatic classification of the point cloud of the keep tower into constructive elements. This is the outcome obtained for the first level of the exterior cloud, distinguishing between wall, merlon, deck, and roof, and then the second level as well, separating between ridges and roof panes, both achieving metrics of around 99% overall accuracy. It is noteworthy that about 25% of the 3D point cloud was employed for training tasks of the random forest algorithm. If we take a look into the interior cloud, this time the level 1 distinguished between vertical profiles, boards, slabs, and roof frames, which were then separated onto ceiling boards, timber joist boards, and trusses. Once again, all achieving metrics of around 99% overall accuracy. Once the classification tasks were done, the automated damage analysis phase started. First of all, taking a look into the roof panes, each of them was fitted to a plane from whom distances were obtained. In this case, none show significant sinking, which means that apparently they may not cause issues related with water accumulation. Then, checking the distances from the deck to a horizontal plane, the proper functioning of the sink system is assessed. Regarding the merlon stability analysis, once the mass center was obtained, the inner third of the section of the merlon was ruled as safe. The orange section represents those merlons within this safety coefficient, reaching a maximum inclination of 5 degrees. Over this limit, tensions will start to appear until reaching the limit inclination of 15 degrees, colored in red. Subsequently, employing a cloud to primitive distance method, an out-of-the-plane movement is observed, showing a triangular collapse mechanism most likely produced by previous problems at the roofing system, which has been replaced. Taking a look on the inside, the inner wall does not differ significantly from the outer one, which means that they do behave as a rigid block. Thanks to the use of the algorithm Ransack, more specifically the layer leftovers, it is possible to observe an homogeneous degradation at the joints of both walls and central pillar. Once again, employing a horizontal reference plane in order to measure the distances, both first and third floor do not show major problems, while the second one shows evident differences at one of its corners. Taking into consideration the differences between beams at ancient timber structures, this slab is analyzed with the help of an ad hoc script, starting with a section along its axis. A third-grade polynomial is applied, corresponding to a beam with pinned supports with distributed load. Bearing with issues related with its irregularity, only the principal beams were analyzed as they are kind of squared. Finally, employing a criterion of relative deflection of 200 times the length of the beam, none of them do show major issues. To sum up, these are the conclusions and future works planned. The proposed methodology exhibits significant promise in enhancing building diagnosis processes in a comprehensive manner. Geomatics play an indispensable role within architectural heritage texts, and they do demonstrate robustness and speed. This tool offers considerable time saving compared to manual analysis. Regarding future works, further validation in terms of consistency and reliability is required. An extension to additional case studies, which may provide with further broadening of these methods' applicability. And there will be developed a tool with the capability to integrate all these processes in once. Thank you so much for attending this presentation. We will be truly pleased to answer any further requests.